Let's talk about the ear, and we're going to talk about both how your ears process sound and how they sense equilibrium and movement of the head. We're going to start with the external ear and work our way in. So the external ear, the fleshy part of the ear that you think of as your ear, is called the auricle or the pinna. And we've seen that word auricle before. Remember that the sacrum and the ilium both have an auricular surface that was sort of ear-shaped. Okay, well now we have an actual auricle that is, surprise, surprise, actually shaped like an ear. The auricle is kind of funnel-shaped so that it actually directs sound waves into the external acoustic meatus, which is this tube here. And you remember that's that tube that goes into the bone of the temporal bone. It also protects these structures inside the ear. And the hairs around the entrance to the ear help to guard the opening against foreign materials getting in there, produce wax. There are glands there that produce wax that trap dust. So that's really important for protecting this ear canal. The eardrum is called the tympanic membrane. And that is the end of this external acoustic meatus and the end of the external ear. This is what the tympanic membrane looks like at high magnification. And you can see that the malleus, which is the first of the little ear bones, actually sits against the tympanic membrane. So as the tympanic membrane vibrates with sound vibrations, the malleus is going to vibrate as well. So now we can see this cavity behind the tympanic membrane, which is the middle ear. And this cavity is filled with air, and it's called the tympanic cavity. And it houses the three tiny little ear bones, which are called the auditory ossicles. These ossicles are going to vibrate in response to vibration of the tympanic membrane. So the tympanic membrane vibrates, the malleus, or the hammer, which sits against the tympanic membrane, it vibrates. Then it transfers that vibration to the incus, also called the anvil, and the incus transfers that vibration to the stapes, which is also called the stirrup. As those vibrations get passed along, they get amplified at each stage of this transfer. So the vibrations of the stapes are a little stronger than the original vibration that hit the tympanic membrane. The stapes sits up against another membrane called the oval window. It's a little oval-shaped structure that separates the middle ear from the inner ear. Now the middle ear also has a tube connecting it to the nasal cavity. And this tube is called the auditory tube or the eustachian tube. And it opens into the nasopharynx at the back of your nasal cavity. The inner ear actually sits in spaces within the temporal bone. And these sort of curvy spaces inside this bone are called the bony labyrinth. Those are filled with membranes, which are called the membranous labyrinth, and then those membranes are filled with fluid-filled tubes and spaces. The parts of this inner ear are the semicircular canals from the top here, or semicircular ducts, the vestibule, which is this area here right behind the oval window, and then the cochlea is this snail-shaped curvy thing down at the bottom. All of these have perilymph, which is fluid between the bone and the membrane. And that's going to sort of cushion these membranes against the bone and also support them and keep them healthy, keep them from bouncing against the bone. The vestibule here opens to the semicircular canals, as I said, and then the cochlea here. The vestibule and the semicircular canals process movement of the head. So those are responsible for your equilibrium and balance. And then the cochlea processes sound. So that's your sense of hearing. Notice that there is a nerve extending from each part of this. So this branch is called the vestibular branch, and this is the cochlear branch. Together, they are going to become the vestibulocochlear nerve, which is, of course, nerve number 8. Never remember. And together they're going to extend through the internal acoustic meatus there. So let's zoom in on the cochlea and learn how this actually processes these sound vibrations. So what we're looking at here is a section through the cochlea with the cochlea sort of unwound. So you can imagine that the cochlea was wound up more into that snail shape, and then for this image they've unwound the cochlea and then sliced it so that we can see the various tubes inside. So here's the tympanic membrane, the auditory ossicles, the oval window, and then the tubes inside the cochlea. So the center is called the cochlear duct, and that's this sort of light purple space there. Above that is the scala vestibuli here, and then below that is the scala tympani. Okay, or this is the vestibular duct, and this is the tympanic duct. The vestibular membrane separates the cochlear duct from the vestibular duct, and the basilar membrane makes up the floor of the cochlea. And those directions only make sense when you think of the cochlea uncurled. When it's curled up, of course, the bottom becomes the top and the top becomes the bottom. So we're going to talk about them as though it's straight. When we look at a cross-section this way through the cochlea, we see this. Okay? And so what we see is here's the cochlear branch of the cranial nerve 8, and then this is that portion that was unwound here. So imagine we're looking at a cross-section through here. So we've got the scala vestibuli, and then the cochlear duct, and then the scala tympani. And we can see the vestibular membrane here, the basilar membrane here. So when you hear sound, the pressure waves from the sound enter the external acoustic meatus, they vibrate the tympanic membrane, that vibrates the malleus, then the incus, then the stapes. The stapes vibrates the oval window vibrates the fluid inside the scala vestibuli. So this is paralymph fluid inside this tube here. The vibration of that fluid then vibrates this vestibular membrane. The vibration of that vestibular membrane vibrates fluid in the cochlear duct. And then the cochlear duct vibration vibrates the basilar membrane and this thing on the basilar membrane called the spiral organ. And then on this spiral organ, which we have a zoom in here, we have these little sensory cells called hair cells that have little hairs that stick up, and those move in response to the movement of the fluid and a membrane that are part of this spiral organ. The movement of those hairs on the hair cells then causes an action potential in neurons, and then the action potentials from those neurons are sent down the cochlear nerve, the vestibulocochlear nerve. Excess sound vibrations go through the basilar membrane, vibrate the scala tympani space, the fluid, and then travel back out into the middle ear through this space here, which is called the round window. Okay, and the way I keep these two things straight, the oval window and the round window, is that the oval window matches the shape and size of the bottom of the stapes. And the bottom of the stapes is an oval like the bottom of a stirrup. So this is the oval window, and then this one is the round window, which is the bottom of this round duct here. All right, so that's what we're looking at here. Here's our cross section. We can actually see this little dark space there. That's the spiral organ, which we can see here. We can see the basilar membrane, those little hair cells, and then the neurons that fuse together to create these cochlear branches of cranial nerve 8. And then zooming in on this, we see this. Now in this diagram, we can see not only the stereocilia, which are the little hairs on these hair cells, we can also see this membrane over them called the tectorial membrane. The tectorial membrane is going to be vibrated by movement of the paralymph inside the cochlear duct. And it's actually that movement of the tectorial membrane that's going to move these hair cells, or these stereocilia. And then that movement causes a change in the hair cells, which then gets transferred to the neurons, which pass an action potential down through their axons. So there we have that again. There we go, nice and big. Okay, so now you can see all of those structures there. We do have hair cells here, which are called the outer hair cells, and in here, these are the inner hair cells, just two groups of cells. And then notice we have supporting cells around those hair cells and those neurons to support and protect those, kind of like we have in other places. When we look at a microscope slide, we can actually see these individual structures. So this is the tectorial membrane. This is the cochlear duct up here. And these are the little hair cells right here. You can see their little nuclei there and there. Here are the supporting cells, and then the neurons here carrying the signals out through the nerve. Okay, there's the basilar membrane with those neurons.